Welcome to Matematika. Today we're going to simplify radicals, that is the square roots and cube roots. The very common questions that you have been asked when you were in Algebra 1 or Algebra 2 is finding the perfect square root or perfect cube root. So for example, we have a square root of 169. We know that when we multiply two numbers and then getting the square root of that two numbers, you have a perfect square. All right. So for example, square root of 169, that is 13, right? Because when you multiply 13 times 13, it's giving you a 169. So finding the square root, the value is 13. B is a cube root, meaning we have to find a number when you multiply 3 times will give you 125. Of course, that number would be 5 because when you multiply 5 times 5 times 5 3 times, it's giving you 125. So the cube root is equals to 5. Same thing with the cube root of 27. What number when you multiply 3 times will give you 27? And that is 3 times 3, that's 9, times 3, that is 27. So the cube root of 27 is equals to 3. How about the square root of 53? Is 53 a perfect square root? Because if we have 6 times 6, that is 36. And we have next to 6 is 7 times 7, that's 49. And then next to 7 is 8 times 8, that is 64. That means 53 is not a perfect square. So, what is the square root of 53? We get the calculator and get the square root, and that's equals to 7.28. How about square root of 64? Is 64 perfect square root? Yes. 8 times 8 is equals to 64. That means the square root of 64 is equals to 8. All right. Let's try to simplify each expressions. I prepared here different, expressions, radical expressions, and we'll see with different operations. Number 1, this is a simple one. Square root of 125n. Is 125 a perfect square? No, right? So what we're going to do is we have to factor 125 in such a way 1 is a perfect square. So if I divide 125 by 2, cannot be. 125 by 3 cannot be. 125 by 4 cannot be. 125 by 5. And I will have a factor of 25 times 5 will give me 125 in such a way that one of the factor is a perfect square times n. That means we take out the square root of 25, that is 5, and what remains inside the radical sign is 5n. Okay? So your answer is 5. square root of 5n. How about the square root of 216m? 216 is not a perfect square. So what you're going to do is try to divide it 216 by 2. Yes, we can, but one is not a perfect square. By 3, by 4, by 5. I could go higher by dividing 216 by 6. And I could get 36 and 6 as a factor. So square root of 36 is perfect square. So we take out square root of 36, which is 6, times the square root of 6m. And this is already in simplified form. How about square root of 512k squared? Alright, that's a little bit a higher number. I could start dividing 512 by 2. That would be equals to 254. Let me see, I'm getting my calculator here. So I'm gonna have the square root of 256. 512 by 2. How much would that be divided by 2? I'll have 256. Okay, sorry for the delay. I have a square root of 256 times 2 times k squared. Is 256 a perfect square? Yes, square root of 256 is 16 times 16. So that is 16. And I have the square root of k squared. So we take out k as the square root of k squared times the square root of 2. What is left is 2 inside the radical sign. And that is the answer. Alright. Let's have number 4. A negative 4 times the square root of 216 x squared y squared z. Alright. So I will write this as negative 4. How will I factor 216? Will I do by 2? Cannot be. By 3? By 4? By 5? Okay, I can do 216 by 6. That is 36 times 6 is 216. Then x squared y squared z. Alright. So I can have negative 4. Square root of 36 is 6. I put that out inside the radical sign. And then x squared, square root of x squared is x. Square root of y squared is y. And what is left inside the radical sign is 6 and z. Alright. So our answer would be a negative 24 xy square root of 6z. Alright. How about number 5? We have a negative 2 times square root of 36 x squared y to the third power c to the fourth power. Okay. Let's factor out first. I could pull out square root of 36. That is 6. I could take that out. Square root of x squared, that is x. How about y cubed? I could factor out y cubed to y squared and y. Okay, I'm gonna show why it happened that way. Alright, I'm going to rewrite this again. Negative 2 square root of 36 x squared y to the third power and c to the fourth. Right? Let's simplify inside. 36 x squared. I could factor out y cubed as y squared and y, and c to the fourth can be, we can take out the square root of that. So we have a negative 2, square root of 36 is 6, square root of x squared is x, square root of y squared is y, and square root of z to the fourth is c squared. And what is left inside the radical sign is this y. Alright? So that means the answer would be a negative 2 times 6, that is 12. What is the higher degree here? Z to the second power, xy, square root of y. This will be the answer. Okay, I'm gonna move number 6 down here to have a space. This is number 5, right? Okay, I'll have number 6. Number 6 is right here. I think I'm going to do some division here. Okay, this looks like a work of when I was a student before. Well, anyway, square root of 27 a squared plus b plus a square root of 12b. We can see that we can factor out. We have to factor out the first radical. So the first radical in such a way, factor 27 in such a way, 1 is a perfect square. So I could factor out as 9 and 3. Since 9 is a perfect square, a squared b plus a, I could factor 12 as 4 times 3, square root of b. So we can take out 9. Square root of 9 is 3. Square root of 3, we cannot simplify that. Square root of a squared is a. So what is left inside is 3 and b. Okay, cannot be simplified anymore. Plus a times square root of 4 is 2. And what is left is 3b. Okay. So 3a square root of 3b plus 2a square root of 3b. And I could combine terms. 3a, this, plus 2a. And the common factor is square root of 3b, which is 5a times the square root of 3b. This is the simplified form. Okay. I will move like the number 7 here. I'll bring this down. 3 square root of 6a cubed minus 2 square root of 24 a to the third power plus 2a square root of 54a. Okay, I could erase this. I was not thinking of, the right space. Okay, let's do this. If we look at the first radical, we can simplify, the a to the third power. Square root of 6a cannot be simplified, but 6 to the third power, I could factor that as a squared times a. Then 2, square root of 24 can be factored out. 1 is perfect. 4 times 6, right? And a cubed is a squared and a. And 2a, square root of 54 can be factored out as 9 and 6a. Alright, I can have a perfect square. 3, what I can pull out from here is the square root of a squared, which is a. So what is left is 6a. Okay? Minus 2, what I can pull out as the perfect is square root of 4 and a squared. So that would be 2. Square root of 4 is 2. Square root of a squared is a. What is left is 6 and a. Then we have 2a times square root of 9 is 3. 9 times 9. And what is left is 6a. Okay, let's simplify. 3a square root of 6a minus 2 times 2, that's 4a, square root of 6a. 2a times 3, that is 6a, square root of 6a. So combine. Common factor is square root of 6a, right? So we can combine 3a minus 4a plus 6a times the square root of 6a. So 3a minus 4a plus 6a, that is 5a, a square root of 6a. Okay. Right? We have number 8. Square root of, I think I need to bring this down. I need a bigger space. Let me do this first. I'm giving you an example of a cube root. So cube root of 125 and 10 is the cube root of 54. So that I could erase this. And I have a bigger space for number 8. So number 8 is the square root of 100 x to the power of 12 y to the power of 8 divided by the square root of 45 x to the power of 10 y to the power of 7. Alright. Remember, you can, it's much easier to bring them to one radical since both are square root and we see a common base, so it's easy for us. So this will be, I could divide 10 by 45. I could have x 12 over x of 10. I could have y to the power of 8 over y to the power of 7, since they have the same base. All right, let's simplify. 100 divided by 45. What is common between them? I think I could factor out the 45 by 5 times 9, right? And the x, I could subtract, because this is division, you subtract the exponent. That's quotient rule. So quotient rule, 8 minus 7, right? So 100 by 5, that's my purpose of doing it. That is 20, and we have the square root of 9. I just put this, I will get the square root later on. Oops. I still have the bigger one. So this will be 20 over 9. So x to the second power, 8 minus 7, that's equals to 1. Or y to the first power, or simply as y. Alright, let's get the perfect. So I could factor out 20 as 4 and 5 to get the perfect square root. In square root of 9, so x squared y. So which one I could take out? This is, all of this are under the radical sign. Square root of 4 is 2, and square root of 9 is 3. 5 cannot be simplified, but x squared, square root of x squared is x. So what is left inside is 5y. Alright, you got it. That's simplified. Let's do something like a cube root. Okay? So 9 cube root of 125. What number, when we multiply 3 times, will give us a 125? Isn't it 5 times 5 times 5? So the cube root of 125 is 5. So 9 times 5 is 45. Okay. How about cube root of 54? 54 is not a perfect cube root, right? Let's factor out. Let's say if we divide 54 by 2, what do I have? 27, right? And 2. Is 27 a perfect cube root? But what number, when you multiply 3 times, will give you 27? Isn't it? It's 3 times 3 times 3. That is 27. So the cube root of 27 is 3. But the cube root of 2 cannot be simplified. So this will be your answer. I hope this helps. And you have, remember, simplifying radicals. When you have your algebra, I think this is algebra 2. all right, and some are in Algebra 1. Okay, so if I can do it, so can you. Okay, can you check the like button and press the subscribe. Okay.